So when you see the word given, anything that comes after that is your condition, and that goes in the bottom of your fraction. So given that he or she used a placebo, so make a fraction bar, go to the bottom. Let's see, placebo. Where do I, placebo, these two. Whoopsies. Oh, all over the place. So these two. So 1,200 plus 400 is what goes on the bottom. And if you want to add them in your head, that's fine. But I'd like to show all the work, at least for the first few. And then the next part is, well, find the probability the test remained healthy. Come on now. So my healthy ones is just the ones that is right there. Okay. So that's my 800. Okay, so given that they had a placebo. Oh, that's not the wrong one.
Yes, isn't it 400?
Would it be added up or only?
My bad. So it's just going to be the 400. Okay.
So it's not just.
So 400 over 1,600 is 1/4. So I'd like you to stick with the fractions unless you see decimals in the original problem. Gauge where did it work? You in? Okay. See if you can do the second one on your own. Same idea. Look at the given. So given that the subject was healthy, so all the people that are healthy, and then find the probability that these, with the healthy people. So instead of going up and down, we're going left to right. So 800 plus 400.
12.
Okay. So 800 plus 400. And we're looking at the people who used the placebo. So we focus in on that 400. Okay. So that's 400 divided by 1,200. And that's it. Okay. So you can always dump this into Desmos, copy paste, and then click on that fraction bar to get your simplified answer. Questions?
No question.
Okay, so see how the denominators are constantly changing based on your given information or the condition. In this case, the condition was healthy people. All right.
Should there ever be a whole numbers, or is that like?
I'm sorry?
Should there ever be like a whole number, like 1, 2?
No,
3?
ever, because of probabilities.
No.
Probability should never be bigger than 1. Okay. I don't know why it's twice there, so take a look at this one. Find the probability a student is a boy, given that he's going to college. So you add up all the people that are going to college first, and then just the boys. Find the probability a student will attend college after the high school if. So the word if is the same as the word given, okay? So start with the girls. On the top one, start with the people going to college.
So 3.
Boy, this is girls.
So,
Yeah.
just looking at the given, make the fraction bar. Going to college, so you have to find going to college. Going to college, yes. So it's these two. So add those two together first.
718.
So 718.
Yes.
Okay? Up top, we're only focused on
Boy.
the boys. So 342 over 718. And then simplify. And I believe
171 over.
it's just 2 is my GCF, so 171 over 359. Okay? So this one.
English the girls.
So starting with the girls. So we take too many crickets. These two numbers and add them together, and that's 514. Oopsies. So 514. Come on now. There we go. So fraction bar 514, and then up top there are 376 girls. So equals 188 over 257. 257. Questions?
Whoa, my thumb.
Okay. So the difference between this and the stuff we were doing the last few days is my denominator is going to constantly change based on my given information. You will not always be given a table, but in this case you are. So this time you're given the numbers, but you have to convert it into percent. So you're going to get a fraction, change that fraction into a decimal, and round it off to the nearest tenth of 1%. and figure out which one comes closest. Okay, so take a few minutes, give that one a shot. All right, add them up. So given that he or she is a junior, so I'm only looking at that column. So we got 312. And then we're looking for the varsity athlete. Well, there's only 36 juniors that satisfy that. So 36 divided by 312 is, well, let's just do a little copy and paste.
That's a lot of JV.
So about 11.5%. Okay. So squigglies. So we're looking at C. Okay. Now, this is an ACT type question. Okay. If you see this on ACT, I wouldn't even go this far. I'd say, okay, 36 over 312, this has to be more than 10%. Okay, but not close enough to 19. So these two are too far away, and this is closer to 10%, and that's why it's 11.5. Okay.
Okay, we're gonna have like
You'll have Desmos, but again, you have 60 minutes to answer 60 questions. We're going to talk more about techniques, about how you're not even going to try to get all 60 done. It's just a waste of your time. Okay. The people who get the 60 questions done are the people that already take calculus by the end of their junior year, which is nobody in here.
Okay. I do it. Let's go.
All right.
Easy.
What's missing? The table. So we will make one. Go to the shapes tool. Go to the rectangle tool and make a big old rectangle. Okay. We have two different conditions, so we're going to need to make two lines. So make line tool. Hold the shift key down. We're going to make a couple of horizontal lines. It's okay if they're not equally spaced apart. And a couple of vertical lines.
Yes, I physically see.
And then take a look and see if you can figure out labels. Okay. If you want to wait, because it depends on whether we put in a horizontal and vertical, but really doesn't make a difference how you label it as long as you have. You're gonna have 4 different labels. See if you can figure out what the labels are first. Take about 30 seconds.
See? No, why does 8?
Can't dogs.
No, I can read it as long as I can read it. Fine.
Stretching.
Don't judge.
Heart dogs.
No.
Don't forget the stretching.
Coat dogs. Oh, the dogs that wear coats.
That's amazing.
Dog coat.
No. Never.
All right.
Isn't there a movie about that? Some like girl want to make a.
101 Dalmatians.
Yeah.
All right.
Cruella de
So, give me 2 designations that are similar but describing 2 different things. Dogs and cats. So dogs, not depot. Dogs, tap, 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 cats. So if that's dogs and cats, we have to have our female male. So let's say female. And then enter, 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 male. Okay. And then put in the numbers in the spots where you think they belong.
Dang.
So notice, they don't give you enough numbers to fill in the whole chart. You have to figure them out. So some of them are obvious and you can put them in specific places, and some of them you're going to have to do a little bit of arithmetic.
I swear they didn't save on purpose. It's 6.
I'm gonna die if I didn't say
Filling it out. Okay, I look at my first number and I see it's 24 dogs. That's total. So I'm going to put 24 down here. So if you wanted to put a third row in there and put total, that's okay. I got 18 cats. 8 other dogs and 6 of the cats are male. So 8 other dogs And 6 of the cats are male. So I don't know how many female, but I can figure it out just by subtracting. So subtract up. I got 16 and 12. Okay, and now I have everything I need to answer my questions. So, probability. So this is how we're going to write this. Capital P for probability. Parentheses. Probability that the pet is male. So capital M given. So we make the vertical bar right above the enter key and shift that it is a cat. Close parentheses. Okay. Oh, you're not gonna be nice.
Yeah, let's do that.
All right, it's because of that vertical bar. That's all right. Equals fraction bar. So given it's a cat, so I've got 18 cats, and 6 of them are male. So equals 1/3. Okay, questions? So I am not going to. I'm going to use text box on this one because I'll make it look prettier. Because you shouldn't have 2 sets of parentheses here. So capital P, parenthesis. The pet is a cat given it is female. So cat, vertical bar, female, close, equals. And then I'm going to use my equation editor. So it'll look prettier. How many females I got? I'm going to have to add across. I got 28. And then how many of those are cats? 12. Okay. So else GCF is 4.
Yep.
So 3 sevens. Questions? Okay. I don't have to see a chart, but I highly recommend it. Okay. This first one you probably could have got away without using a chart, but the second one probably not. Okay. Questions? We don't timeline. Oh, no, okay. All right. This one's a little different. They took all the data and already converted them into probabilities. So the probability, okay, so we got a table showing a poll of randomly selected high school students. They were asked if they think smart shown be allowed in class. So 15% of 9th graders said yes. 12% said no. The total 15% of all the students in the school are 9th graders who are saying yes. So if I add up all of these, I should have 100% or the number 1. So that's why there's a 1 in the bottom right. So when you're calculating these probabilities, if you get something bigger than 1, you did something wrong, okay? Because your denominator is always going to be bigger than your numerator. So let's do the first one together and then set you loose on the others. So make an equation bar, box, and then bar. So the bottom. What is the probability of a 9th or 10th grader? So that's my given, 9th or 10th grader. So I take these 2 numbers, 27%, 27%, or 2700s, 2700s, add them together. So I'm going to show the arithmetic on this first one, and I think I'm going to go back to pink here. Oh, let's go back to pink. Come on, pink. There we go. It's going to stand out against the black. So 27% plus 27%. And then we're saying yes. So we're just taking the yeses. So it's 15 and 16. Okay. So 0.15. Okay. Right. Remember I said write your answer in simplified fraction form unless you're given decimals. And since I'm given decimals to 2 places, it is understood that my answer should be written to a decimal to 2 places. So do a little Control A, Control C, go to Desmos, paste. So 57% or 57 hundredths. Okay? So make a squiggly here because it's not exact. So 0.57. I don't necessarily need to see the arithmetic, but I would recommend it at least until you really understand what's going on here. Okay? So see what you can do at 2, 3, and 4.
Just 2 really easy.
Have you been to the White House?
Yeah. I've been around it for a few years.
Yeah, but nobody lets anybody in the White House anymore.
Outside, yeah.
All right. So how many 11th graders we got? 24%. So that's on the bottom. And the ones that said no, not a lot. So is that about 21%? Okay. So 9th and 11th graders. So fraction bar. So I've got 2.7 and 2.2. No, 2.7 and 2.1. 9th or 11th. So that's 51% of the students. And answered yes. So 15 and 14. So 34. What's that simplified to? 6.7. Yep, it's about 2/3. Probability a 10th or 12th grader answered no. So fraction bar. So 27 and 22 is 49. And then no is 16%.
Yeah.
And what's that simplified to?
0.11 plus 0.004.
It's 15.
It's 15.
Yeah.
So what's that simplified to?
0.31.
Questions?
No question.
No, sir.
All right. So last thing we're going to do, we're going to start the prompt today and finish it tomorrow. I want you to fill in as much as you can in the chart first, and then see what you can do in answering the question. Okay? So there's missing pieces, and if you can answer the 2 questions before we leave, great. But we're not going to go over them until tomorrow, beginning of the period.
What was the last one? That was really easy. It's just walk through